Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly machine learning with R. How we can easily implement the different types of machine learning with R programming language and also make the classification, mainly land use, land cover classification using RGE package. Okay. So mainly today I also try to discuss about these things, how we can easily make the classification such as forest and non-forest region from a satellite images. So here you can get the output look like that. So basically this green color pixel value identify the forest region and red color identify this is the deforestation region. Okay. And today I also try to discuss about that support vector machine algorithm, how we can easily implement the support vector machine algorithm in our programming language. Okay, so let's go our class. So in this time I use here this R studio. So here I already opened the R studio. Okay, so first of all I need to import the library. So I simply use here the library function and call my library RGE and click to the run. So it will be successfully imported, and also use here the EE initialization for that and click to the run. So now it will be successfully initialized with RGE platform. Okay, so this is the first step. I simply import my library and also imported the initialization of Google Earth Engine platform. Okay, so in this time, first step I need to input the image. Okay, so I need to input the image in here. So input image, which image you want to make the classification. Okay, so in this time you can use the different types of satellite image. If you want, you can use that the Landsat, Sentinel, surface reflectance of Landsat, then also top of atmospheric of Landsat, raw image, anything you can use. So in this time I use this image. This image I want to use. Suppose Landsat 8 image collection raw scenes. This image I want to raw sense image or raw image I need to use. Okay, so for that what can I do? Just I simply copy from here, okay, and paste in the R studio. Okay, so in this time, instead of the dot notation, I just simply put here the dollar sign. Okay, so this is the syntax of the R studio, and then give a variable name. So I put the variable name such as, you can use any variable name. I put the variable name such as image or L8. You can use any name. I put the L8. Okay, so now this is my image collection. This image collection I stored in this variable L8. Okay, so I run the code and check. Okay, so it's successfully run. There is a no problem in my console. You can see there is a no problem. So now this image collection I need to filter. Okay, so there's a lot of way for filtering using the filter bounds function, filter date, filter metadata. Lot of way we can filter, but in this time I use a algorithm, E algorithm, Landsat, simple composite. I want use this algorithm and filter it. So if you want to know about this function, so just I simply go Google Earth Engine code editor and click on here about this function. Is that EE dot algorithm dot Landsat dot, yeah, simple composite. Yeah. This algorithm I want to use in here in this time. So in this algorithm, you can see a algorithm Landsat simple composite. Okay. So basically it's the collection. Okay. Percentile, cloud score range, and also max depth and asphalt. Okay. So all of this argument I can easily use. So basically, what this function give me? It compute the Landsat top of atmospheric composite from the collection of the raw satellite imagery. Okay, so in this time I use here the raw satellite imagery. From this raw satellite imagery, I need to compute the top of atmospheric composite using this algorithm. Okay, and this algorithm also calibration and there assign a cloud score to each pixel using the simple land set cloud score algorithm. Okay, and it selected the lowest pixel range of the cloud score at each point. Okay, so I use this algorithm. Just I simply copy, okay, and paste in my R Studio. And in this time, instead of the dot notation, just put here the dollar sign all time. I need to put in there's a syntax of the R Studio. Just I simply change it. Okay, and after that, I just simply put here the parenthesis. In this parenthesis, first of all, I put here the collection. So I put here this collection. So this is my first argument, collection. So I mentioned the collection in here. Collection will be L8. Okay, so this is my L8, which is stored the full image collection. Okay, this L8 I just use here a function, filter date function. So use here the filter date function and put my specific time period. Suppose I put the time period is that year of 2018, 1st January from suppose year of 2018 or December, suppose 31. Okay, so this is my first argument I fill up in here. So collection I put in here. Okay, so after that I need to use here the another thing is that asphalt. Asphalt, I simply put here the asphalt and I simply use that the boolean operator is that true. Okay, so it's done. So I put here this composite look like this way. So I simply all of those things stored it in a variable. So just put the variable name, suppose image. You can use any variable name as the image. Okay. So now check it. Simply select and click to the run. What the happen you can see. Okay. Okay. So you can get the result look like that. Okay. In this time. Okay. So in this time we also need to just put here this another thing is that I can get the error in here. You can see error in L8 filter date function. I put the error in here. So first of all, I say okay. In this time always without the dot notation, we need to put here the dollar sign. Otherwise, we can get the wrong. Okay. So now I hope it will be work. So click to the run. And it will be FLOAT. Okay. And then simply click run again. So I hope not will work. Yeah. So now there is no problem. You can see it is successfully run about this composite. So it will be work. So now if you want to display the image on here, which image you want to got in here. So for that, what can I do? Just I simply add here the image. So just add a layer. Suppose put here the map, add layer. Okay, and call the image. Simply copy that and paste in here. And after that, just we can simply click to the run. So it will load it. Yeah. Okay. So we can get the image look like that because I did not set any types of pen combination. Okay, so that's why it look like that. So now add here the visualization about that. So for the visualization, so I put the variable name suppose as a VIS. You can use any variable name VIS. I put the variable name as a VIS. And in this variable, just I simply mention all of those band which I want to display in here. So I make a list. So use here the list function, list. In this list function, I just simply put all of those bands. So put here the bands, which band I want to display in this time. Okay, so I make a list again, all of those bands. So put here, I want to show the result for red band. So put here the B4, red band. Then put here this band for green band. So put here the B3. And then put here the band for the blue band. So B2. Okay. So after that, I can simply put here this mean max value. So for that, I simply use at the max reflectance. So suppose max will be just put at the 0.5. Okay, I put the randomly and put here the gamma. Gamma, I put at this gamma is that 2. Okay, and after that, just after the object name image, I put here this variable name vis. Okay, this variable name is simply call. So now I add this visualization. So now click to run again. Okay, it loaded. So now we can get the visualization of the natural color. You can see. Okay. So now it's loaded this satellite imagery. Look like that. You can see. So in this time from this satellite images, just we classified the two things, forest region as well as also non-forest region. Okay. So for this classification, first of all, I need to import the bands for prediction. Okay. So in this time, I make a list. So in this list, I store all of those bands which I use for prediction. So just I simply comment about that for the understanding. Use this bands for prediction. Okay. So I make a list about that. So take a variable bands. In this variable, I just store all of those bands one by one. So first of all, I want to predict for B2. Then put here this B3. Then also put here that about suppose B4. Then B5. Put here that B6. B7. B8. So okay, give me the B10. Okay. After that, we put here this B11. Okay. So this type of band I use for the prediction. Okay. So in this time, I simply okay. So I select and click to the run. We check any problem. Okay, there is no problem. You can see it successfully worked. So in this time, I put all of those bands which I use for the prediction. So mainly all of those band pixel value I want to extract from this training point. Okay. So in this time, I need to take the training point from here. If you want, you can also use the polygon about this training point and also work with that. Okay. So in this time, for this training point, first of all, we need to take the some training point from the forest region, as well as you can also take the training point for the non-forest region. Okay. Then make the training point. Okay. So it is a supervised machine learning method. Support vector machine is mainly supervised machine learning method. So that's why first of all we need to use here the training data or label data or pre-categorized data. Okay. Then use here the support vector machine and make the classification about that forest and non-forest region. So first of all, I simply imported all of those training points from here manually. So this is the manual create polygon. Just I simply copy the code from here. So basically in this time it show the result about that manual forest polygon. This is the forest one and forest two. We take the two polygon for the forest and non-forest. We also take the two polygon. Okay. So this is the polygon about that forest and this is the polygon for the non-forest. Okay. So this is the two. This two is that for forest region and then two is for that non-forest region. Okay. So in this time for this polygon, I just show the result about that. Okay. Just I need to show the result and also get the training pixel value. Okay. So first of all, I need to create the code for showing the result as a polygon from that. So for that, what can I do? So for that, first of all, I need to make a feature collection from the handmade geometries. Okay. From basically this is the handmade geometries, and from this handmade geometries, I just make it as a feature collection. Okay. For the feature collection, what can I do? Just I simply take a variable. Suppose I put the variable name is the polygon. You can use any variable name. I put the variable name is the polygon. Polygon. So in this polygon variable, or I put here this all of those things. So I make a feature collection. Okay, all of this training polygon I simply make as a feature collection. So for that, I simply use take a variable and put here the ee dot feature collection. Feature collection. But instead of the dot notation, all time we need to use here the dollar sign. Okay. I put here this feature collection and all of this feature I mentioned in here. So for that I use here this parenthesis and use here the C and put all of this one by one. So first of all, you can see here, I can make here the first of all e dot feature feature, I take it, and then call here the, suppose I show the result for non-forest one. So call the non-forest one and paste here. And after that, I make a list about that. So use here the list again, and list, put here this class. So put here this class is equal to 0. Okay. So the same approach also for the non-forest too. What can I do? Just I simply use here the comma sign, and instead of the dot notation, we need to put here the dollar sign. Okay. So put here this dollar sign. Okay. So now what can I do? Just I simply copy the same code from here and paste. In this time, I just put here this this, so non-forest 2, this variable, simply copy and paste. Okay. So now I take this feature collection for the non-forest, as well as I also take for the forest region also. For that, I also use here the comma sign and paste again in here. So just I simply copy this code from here and paste. And in this time, I simply call the forest 1, simply copy the forest 1. In this time, I put the class, this forest class is that 1. Okay. As well as also do for the same approach for that, paste in here. So I simply copy the same code and paste and put here this forest 2 and set here the class is the 1. Okay. So now it successfully convert as a feature collection. Okay. So if you want to, okay, so I simply click to the run and check about that, what is the any problem or not. So there is a no problem. So now I display the polygon on my area. So for that, what can I do? Just I simply use at the map dot add layer function, and then simply call the polygons, simply copy and paste here. And instead of the dot notation, we can simply use at this dollar sign, and now click to the run in here. Okay, it loaded. Okay. So now you can see here, we can get the result look like that. We can get the polygon. So basically this polygon, 2 polygon used for that forest region and 2 polygon used for that non-forest region. Okay. So in this time, from this polygon, we are used for the training, okay, point or training feature. So now from this training feature, we need to just extract the information, all of those band value. So all of those band values, pixel value, we need to extract from this, all of those training feature. Okay. For extracting the training feature, we are using here the sample region function. So for that, I can write the code about that. For extracting the pixel value is polygon in the training. Okay. So for that, I simply take a variable. Suppose this, put the variable name is that training. I want to extract the all of those pixel value from this image. This image I already show in here. This is my image. So simply copy the image and then paste in here, and then use a function, this function called the sample region function. So use here this dollar sign and put here the sample regions function. Okay, this function will be used for extracting all of those pixel value. Okay, so first of all, we need to use here the collection. This is the argument about the collection. This argument collection will be just our all of those polygon. Okay, so basically these are collection. So just I simply call the polygons and paste here. After that, I just call the properties. Okay, so keep this list of the properties from the polygon. We can get the list name is the class. Okay, we can see class. So for that, I can simply use here the properties. So properties. And then make a list. So use here the list. In this list, simply call this class. So these are property name class. I put here the class. Okay, so properties and then put here the class. After that, set the scale to get the landscape pixel in the polygon. So I set the scale. So scale is that 30 meter resolution. Okay, so now it will be work for that training data set. So mainly it will be extract all of this pixel value from that. So just I simply run the code, check. Okay, there is no problem about this code. So it in this time it extract all of this pixel value from this polygon. Okay, all of this polygon extract the information from here. So now this is my training data set. So this training data set I just need to add with my support vector machine algorithm. Okay, so how I can add that? So if you want to go to the code editor and check about that support vector machine algorithm or SVM algorithm. So this support vector machine algorithm you can see. So basically there is a lot of argument about the support vector machine algorithm. So if you want to learn all of those statistical part about the support vector machine, then you can easily enroll my this online training program for the support vector machine or machine learning algorithm or deep learning algorithm. This online training program you can easily learn and learn all of those argument about that support vector machine and this argument how it will be work. So all of those things you can easily learn from here. So in this time, I just use this function about the support vector machine and then classified the land use land cover classification map. So further, I simply copy from this function from here and paste in the R studio. Just simply paste in here. So this is my function for create the support vector machine algorithm. So in this time, I just simply instead of the dot notation, just put here the dollar sign. Okay. So put here the dollar sign about that instead of the dot notation. And then I put all of those argument one by one. So first of all, my argument is that will be kernel type. So which kernel I want to use in here. So I need to define here the kernel type. So for the kernel type, basically in this time we are using here the RBF, radial bias kernel type. So I simply put here this argument is that kernel type. And as a beginners, if you don't know what is the kernel type, what is the RBF, then you can easily join my machine learning online training program and learn all of those things about that. Okay. So in this time I use here the RBF kernel type or radial basis function I use in here and also put here the gamma. So basically we can get the two type of gamma in support vector machine, high gamma and low gamma. I put here this gamma is that 0.5 as well as I also need to put here the cost. So mainly cost is the another argument in the support vector machine. So I put here the cost value is the 10. Okay. So this is my support vector algorithm I use in here. So kernel type is the RBF, gamma is the 0.5, cost is the 10. As a beginners, if you don't know what is that kernel type, what is the gamma, what is the cost, then you can easily join my machine learning online training program and learn all of those things step by step as a theoretical part. Okay, so in this time, all of those things I store it in a variable. Suppose I put the variable name is that classifier. Okay, you can use any variable and you put the classifier. So now I just simply check the code is right or not, click to the run. So there is no problem, it successfully run in here. So in this time I train. So this is my model. Okay, this is my model. This model I just add with my data set. Okay, so for that what can I do? Just I simply take a variable, suppose train. In this variable I just simply add. So in this time I simply call this classifier. Okay, this is my model. This model I use for train. So use at the train function, train with my training data set. So this is my training data set, mainly all of those pixel value. Okay, just I paste in here. And after that, I need to mention here the property name. Property name is that class. So use here the class. And then use here this input properties. Input property is the band. Okay, all of those band which I make the prediction. You can see all of those band. I already mentioned here the band. Use all of those band in here. Okay. So now you can see what happened. I simply call my classifier. This classifier I train with my data set. It is my data set. And properties will be class and input properties will be band. So now we train about this image. Okay. So after that, I need to classify the image. Okay. So in this time, I need to classify the image. For classifying the image, I just simply add my model with my image. Okay. So for that, I simply take a variable, suppose classified. Okay. And after that, I simply call my image. So here you can see, this is my image. I already create the composite about this image. This image I just simply add with my classifier. So simply put here this, and use a function, classify function. Okay, classify function. And instead of the dot notation, we just simply put at the dollar sign. And then I simply call my model. So simply copy that, train, and paste here. Okay, so now it create the classified image. If you want to show the result about the classified image, so for that we can simply use at the map dot add layer function, and then call the classified, and then click to the run. First of all, I simply click to the run about that. Okay, there is no problem. Also run that. Okay, and instead of the dot notation, I need to put here the dollar sign. Okay, so now it will be work. So click to the run. So now it will be show the classified image without visualization. But when I put here the visualization, then we can easily find out the forest and deforestation region from the satellite images. So let's go about the visualization about that. So for the visualization, I can simply make a suppose VIS. I put the variable name is that VIS, and in this variable I simply show the colorful about this map. So for that I make a list. So put the list. In this list I put here this mean. Mean it will be mainly 0. 0 means that non-forest, and max is that 1. 1 is that mainly the forest region. Okay, and then also mention about the plated of the color plated. So you had the plated function, and put here the C function for the color, and put here this mention the color. I want to show here the deforestation region, it's showing as a red color. So put here the red, and where is the forest region, it's showing as a green color. So put here the green. Okay, so green. So now I simply run this code again and check about the result. So run and also run this code. So now we can get the result about that red and green. And here I can get the result. Red is that deforestation, and also get the result about that forest region. So in this time I make the mistake in here. I need to simply call the variable name VIS. Okay, then run the code. Otherwise it not work. Okay, so just I paste and click to the run again. So now I hope it will be added the color red and green pixel value, and from that we can easily identify that the forest region and deforest region. You can see. Okay, so now it F2 added. You can see. So basically we can get the result look like that. You can see this is the green pixel value, it's identify the forest, and this is the red pixel value, it's identify the deforestation region. Okay, so in this time we are using here the support vector machine about that. So that's how we can get the result look like that. And further tutorial I also try to discuss about that how we can easily calculate the accuracy assessment, and also make the what the accuracy about this map using the confusion matrix table in RStudio, as well as how we can easily export this type of map from here, as well as how we can easily calculate the area, how much forest region and how much deforestation region is available. So for this type of analysis, we also try to discuss the further tutorial. And in the meantime, if you want to join my online training program with RStudio in Google Earth Engine platform with machine learning, you can just contact with my WhatsApp number or email. I will give all of the description in the video description. You can easily find out that. As well as if you want to join my online training program on Google Earth Engine platform for that JavaScript programming. So basically this is the group training program, and this registration is an open for that 7 days online training program, and this class will be start from the 5th August. Okay, so if you want to join this online training program, I can read all of those things about the course content. Okay, and basically we try mainly focus the beginners who don't have any knowledge in Google Earth Engine platform, or who don't have any knowledge about the programming. So after completing this online training program, you are able to do any types of remote sensing analysis. Okay, so I give the all of this information in the video description. If you want to join this upcoming online training program, you can just contact with me WhatsApp number, as well as you can also contact with this email. Then you can get all of those information and also registration and join our online training program and learn all of those things. Okay, and this online training benefit is that you can get the lifetime teaching support. Okay, so when you face any problem regarding any issue or any code issue, you can get the supported from us. You can get the recorded video class, also get the all of those practice code or slides you can get, and after submitting all of those assignment, you can get the e-certificate. Okay, so if you want to join this online training program, just contact in my WhatsApp group or WhatsApp number or email. I will give all of those information in the video description. You can simply check it and knock me. Okay, so today is no more. Stay safe, stay happy. Thank you for everyone for watching that.